YouTube? It's Drew again with another Cafe Yocto episode featuring the 5-core AM64X system on module. Today's episode we're going to be talking specifically about custom meta layers. What are meta layers? Well, this is really going to piggyback on a previous episode's topic on building the BSP or board support package. The board support package is everything you need to build a Linux software image that allows the 5-core AM64X to boot into Linux. And meta layers organize the instructions for how to build all those components. Those instructions themselves are called recipes. So there's a number of terms floating around here. So meta layers contain recipes. Recipes are the instructions for fetching, building, and installing all the individual components. This thing, the overall image itself is a recipe. And all of that can be found here in the sources directory. So just taking a quick look around together, all the hardware-specific stuff from Phytech, so the SOM implementation, the carrier board implementation, all that is enabled here in Meta Phytech. So you would expect to find a recipe for the bootloader here, a recipe for the Linux kernel, and then you'd also find the machine configs for all the various configurations of the SOM that would be supported. They'll all be found here. In Alpha 2 of the AM64, 5-core AM64X BSP, there's only one SOM config, but as this platform becomes more stable, there will be more off-the-shelf variants that will be available. Right now it's just an alpha release, so early access essentially. But diving further, we have some ARM-specific support here in Meta ARM. We have Qt5 specific stuff here in Meta Qt5. So just kind of painting the picture that all these meta layers are modular. Some come from Yocto project itself. For example, Meta Open Embedded and OE Core, these come from the Yocto project. But Meta Phytech comes from Phytech, Meta TI and Meta Arago come from Texas Instruments, etc. So it's all modular. We're going to make our own meta layer and create a recipe with instructions for building that Blink program we've done before and add it to this image. Okay, so how do we do that? Let's first dive into BitBake layers. This is a great tool to get started with meta layer development and writing your own recipes. So what I'm going to do is specify this command here, bitbake layers, create layer, and I'm going to give it the path. I'm going to call this meta layer meta example. Let's do that and see what's set up in there by default. I'm just going to navigate there. So quick look around. The conf directory, that's going to contain this layer.conf. This is going to specify information for the layer. For example, it would include your layer priority. So some layers, because they're all modular, right, you can set priority between different layers. And then you can also specify the Yocto version compatibility here. So this would get parsed very early on. And if you check out a meta layer, these are all typically source controlled, and so each branch would be like a version of the Yocto. If you checked out the wrong version of Yocto for a particular meta layer, that would be obviously found in the layer.conf, and then BitBake will warn you that, hey, this is not compatible. It'll stop things before you get too far and waste a bunch of time. So anyway, when you create the meta layer with BitBake layers, this is already populated with information that allows this meta layer to work with the current Yocto version. So I'm not going to touch this. And copy to MIT, README, this stuff is important, but not really necessary for our quick crash course example. So really this is not intended as a comprehensive instructional video on Yocto project and custom meta layers, really just something to help you get your toes wet, crash course style. So okay, so meta example, we also have a recipes example directory in here. So this would be the package name. So oftentimes your meta layer might have multiple recipes in it, and then each of those recipes could have like sub recipes where that would be like your dependencies for any particular package. So for here, this is a simple example. Recipes example is just going to have itself as a dependency, no others. So that's just to explain the seemingly redundant naming here of these directories and subdirectory. Let's take a look at the recipe for example for the example package. Recipes are this .bb file format. Let's take a look inside. So we got inside the recipe some information, licensing. So if you're distributing your software under a particular license, you specify that here. And then we can also specify like additional tasks in our recipe. So this is a kind of a pretty weak sauce example, because we're just doing this display banner thing. This is going to print out this block during build time essentially on the console. And then we're just adding that task before do build here. So display banner before do build. So do build is a task that's inherited by all recipes. And that core functionality I mentioned, I hinted at that before. That comes from, I think, OE core. Let me know in the comments if I'm wrong, but I think that's where it is. This is all top of the head. I don't have a script, so bear with me. Now, if I want this to be a little more useful, right, I'm going to have to modify it up. So my recommendation is, as you work through making your own meta layer, is looking at the existing meta layers in the sources directory, especially things that are already installing things by default in your software image. Those are good things to look at because you want to emulate those and anything new. So basing your recipe off of something that you can find existing is a really good strategy in writing these. What I'm going to do is go ahead and switch over my meta example to the actual example, and we can do that by doing this git clone. I made this meta blink here. I can just go grab that. This is actually publicly available, so this is my GitHub handle, T11Phytech, and this meta blink is public, and you could go ahead and try this if you'd like. We're going to take a look at this together. All right, so meta blink, let's see. So remember, I didn't actually touch this at all. This would be the same as set up here in meta example. I've changed the name of things to reflect my application, so meta blink. And then, this only has one dependency, so blink. And then let's take a look at the example recipe now. So this looks a little different. Because I just wrote this blink.c code with you in the previous video, there's no license associated with this distribution. So this closed. This is actually like a hacky way of bypassing all the license checks. So you wouldn't want to actually use this like line as is for like a production system. This is just for like development, and there's a few warnings I think that'll come up during build time. I've gone ahead to and inherited systemd. The goal here is I want to power on my SOM and then have the blink program run automatically. And the way Phytech sets up its Linux BSPs by default is those services are all managed by systemd. So we can inherit the systemd BB class, which exposes this functionality here, where we can just say, hey, I want this systemd service enabled automatically, and I want this service to be named blink.service. Okay, moving line by line, we'll just work through everything. So the source URI conventionally is the repository of the application source code. So this would be like a Git repo. For example, here, you would have that here. However, I'm doing things a little unconventionally just to keep the video short and simple. Actually, I am tracking blink.c, the source code for the application binary, in the meta layer itself. Again, that's not convention. And it's probably better to separate those two things too. So you have your application software tracked in its own repo, and then you have the meta layer that grabs it and builds it in a separate repo. And the strategy there is you can maintain both separately. However, because my blink C is very simple, I just stuck it in the same meta layer and I'm version controlling it here. So you could actually find it in files here. Okay, moving on. We're specifying, instead of a repo, hey, I want you to just grab a local file, and you can do that like this with the syntax. Another local file is that blink.service. We'll look at both of these a little closer in a bit. Now, for the blink package, which this blink recipe is defining essentially, we need to specify what files are going to be included in that end package. Yocto has the ability of packaging things in a number of formats, so IPK or .deb, and you could distribute those files in a package feed or just as a file. or you could bake them into your software images by default. But everything leading up to that, it's all this stuff is deployed as these Debian-like packages. And so files package name, that's what this PN would resolve to. This, you're just going to list out everything that's going to be included in the package. So that'd be the Blink binary, not the source, but the Blink binary from the binary directory, user bin. We'll talk about that a little bit more. And then the blink.service itself too. Now moving on, do compile. We have to specify how we're going to go and compile this C code. And this should look familiar from a previous episode on cross-compilation. We're going to cross-compile that blink.c in the work directory. This is where all the sources are unpacked during build time. And we're just going to compile it and stick the output the blink binary in the same place. And that's the only thing we need to compile, because the service this service file is a unit file that is parsed. It's not compiled. So okay, so that's all we need to do compile. Now in our do install, we have to essentially take these components and stick them in the right places. And essentially, we're creating a directory here in deploy. That's what this this D, capital D, resolves to. In the deploy directory, we're going to create a system unit dir. I believe this resolves to /lib/systemd and then /system. And then we're going to copy the service, or move it, I believe. This syntax is interesting. Bitbake is kind of a strange syntax. So there's a Bitbake manual, like a developer manual, that talks about the syntax and how to do common tasks. So that's what I would recommend checking out for a comprehensive explanation of all this. But we're going to copy the service file from workdir into the deploy dir directory. And then we're going to do essentially the same stuff with bindir. Bindir is user/bin in the deploy directory, and then copy the executable there. Now, because we're essentially going to set up the Blink recipe here, this guy, as a dependency for the TSDK default image. Essentially, that means if I build TSDK default image, I want Blink to be built automatically and included in there. So the TSDK default image already defines a do rootfs task that will go into this deploy directory and package everything up that's in there. So that would include Blink, but it would also include the Linux kernel and your Python support and literally everything else. And it'll package all of that into your end software image. So that's how this essentially works at the end of the day when you build the overall software image. Continue on line by line. The way I wrote this blink.service, it's a good idea to specify bash as a dependency because this blink.service relies on bash scripting. Now bash is already the default, so we could have omitted these last two lines and everything probably would have worked, but it's just good practice to have these checks to make sure that this recipe is only being applied when it's actually applicable. So that's why you would specify bash as a dependency, and then we could also specify what machine we're targeting, and that's important because this blink.c is written specifically for the AM6442 SOC, but more specifically the FiCore AM64X System on Module and Development Kit. So that all comes back to this machine. Okay, we've looked at the Blink recipe. Now we're going to look a little bit at the supporting files. So in here. Now, if you caught the cross-compiling applications video in this series, you should. We covered how this was written and why it's written the way it is and where these numbers come from. All in that video, so go check that out for more information on that. That was just to prove that the source code is the same as before. And then let's take a look at the blink.service. So there's a couple of things in here. Let's take a look. So the description, this would be the string that actually appears during the boot log. That is going to happen after the basic doc target. So I don't remember exactly when this happens, but it should be near the end of boot. So near the login prompt, essentially. Sort of late in boot is what this is going to cause. And then remember from our cross-compiling applications, in order to blink the LED, we had to do a couple things. We had to write the blink program, but we also had to make sure first that the pad config is actually muxed. And so the quick and easy way of doing that was devmem. Well, we can just stick that command from that last episode right into exec start pre. So this is just ran before the service is started, effectively muxing our pin. And then here in exec start, we would actually run the Blink program. We just execute it. Now the service file will also need to specify a way of stopping the executable or the service. So we would just kill all processes named Blink automatically. So this would get handled by system control. And then here in remain and restart, so this we just written this service file in such a way that it'll just restart automatically if anything crashes. Okay, so we've kind of walked through the entirety of the meta layer, and it'd be pretty simple to kind of connect how that was written from the original meta example. Now let's go ahead and try building it. So first thing I'm going to do, navigate into the build directory. Now, I'm going to try to build Blink, right? I can just build the package by itself because this is just a recipe. Is that going to work? It's not going to work. And there's a reason for that. Because we just cloned that meta layer to the sources directory, but BitBake has no idea if that meta layer is active or not. So in order to do that, we'd have to actually add that meta layer here in the bblayers variable in bblayers.conf. So all the meta layers specified here are active. We could manually edit that, but we can also use BitBake layers again, add layer, and then the path to our meta layer. Just like that. And let's take a look. Double check, and it is there. So now I can BitBake Blink.
A few moments later.
All right, so now that is done, let's take a look at our Blink package. And we can find that in deploy. Let's just do Blink. So really, it's coming down to this. I don't believe these ones are going to actually have anything included in them. I believe this is /dev and /debug. These are inherited by some class in the open embedded support. So really not too important. This is the one that we really want, and we can also look a little closer at it here in the recipe info for that. As just mentions some versioning information. That's going to correlate to ultimately the layer's file name, or the recipe's file name. Now, is this included in my software image for the system on module? The way we can check that is by checking the manifest file, like so, of that TSDK default image. And in here, does Blink exist? It does not. The reason is because we just built Blink independently. And of course that will get deployed, but it's not going to get included in the software image. The way we do that, the easiest way, is to just navigate into your comp/local comp, which is used for configuring the build. And we can set up this variable image install append. And we just list the package that we want included. So now if I rebuild BitBake TSDK default image, that Blink package will get included in there.
A little longer than a few minutes later.
There we go. And with that, our TSDK default image is rebuilt. Let's double check the manifest, and we should see that Blink is now included again. And we can also double check that the version information is there. Now, what's next? Well, this next step is to test it out. Let's go ahead and flash this to an SD card and see what happens.
More moments later.
There we go. Now let's go ahead and boot it up. And we can see that my kit is just over on the side here. Just kind of prove, we're going to boot it up. I'm not going to do any user intervention. And we should see this LED just start blinking. Come on, you can do it. And we got blinkage. All right, that concludes this video.
Hey everyone, this officially concludes our Cafe Yocto series, our first Cafe Yocto series. But again, don't forget to subscribe to our channel because we will be doing this again in the future and you're not going to want to miss it. Thanks again to True Loan for doing an amazing job presenting these. And I'm Des with PhiTech and we will see you at the next one.